Hello, good evening. Welcome to this second episode of Let's Make an Amiga Game in Assembly. This is the page of Phaze101 on YouTube. You can see my streams there. The links, you can always see them at the upper right-hand corner. As you know, we have, first of all, this is our Facebook page, so follow us there, not just on YouTube. Here we have our Patreon page with all the content that is available, as I said, on YouTube. Actually, I didn't say this yet, but I've been saying it all the time. On YouTube, there is till episode number 21 of the book, Italian and English, of course, but on Patreon there is still episode 41, as you can see, and episode 1 of this series is there also. However, as I said, I will be delaying those later on. For now, they will be available also because I'd like to encourage you to start coding and show you how to code. So yeah. We also have the same thing with coffee, basically. So if you like what we do and you would like to support us, then those are the two main channels where you can support us. And also, this is recent, we have a Telegram group, and you can subscribe to it. You can reach us on Telegram or on Discord. Most people use Discord, I have to say, but up to you. You're more than welcome. What I was going to say, yeah. So last time, okay, I started this, the project, the game. We created a project also on GitHub, or GitHub, I do not know. Some people say Git, some people say Git, whatever. You understand what I mean. So I said I will be updating this, and I did. Also, actually, before I continue, I need to share, make you aware of this. I have created this page with links to Amiga programming, okay? This is more aimed at beginners. There is not really advanced stuff here except for maybe the books. It's more things that while I'm doing the book and while I'm doing this series, I came across and I thought these will help a beginner. So it's not that I have all the links related to the Amiga programming, but for sure, if you're a beginner, this page will help you. You can get the link to this page by typing exclamation mark commands, of course, and then I think it is, let me tell you, commands, and it is book page. So if you type book page, it should give you the link in relation to it, so you can get this page, and you have access to, I mean, these links are available on the internet. I just group them together. That will help you to code for the Amiga. Let's go back to this. So that now I need to explain what I did. Last time we created what we need to do for the game to do, okay? Game tasks, what we have completed, okay? What we are working on. So game tasks in progress, and then game task completed. Maybe I need to make the screen a bit bigger. Right? Hope that helps. So I added 2 more columns, okay? And in these 2 columns, I made a list of things that I will be doing in the stream. I will try to finish them all. It's going to be tough to finish them all because some of the tasks will take longer than one. But if not, we will add them in the next one, okay? So it's one of those things. The first one, I have done it, so I can move it there. I told you about the links, basically, that I just explained, which is this page, okay? So now I have shared in my on Facebook today, on Twitter, etc. I have shared this link to this page where I am, okay? So to this GitHub page. If you do not have it, I'm going to share it again, and you can see this same page. Of course, you're only going to get read-only to it, but, and I'm going to make sure that it is here and it's done. So that's the page that I am viewing right now, and I hope this helps. Now, the next one is I need to explain a Patreon question that I had. However, before I continue, before I jump into this, I need to say certain things. I know we live in a fast world, okay, and we tend to think we watch a video and we become geniuses. It doesn't work like this in assembly. I had some, I don't want to say, I had some questions in relation to this that made me realize how we think today about when we want to learn something. We all seem to have this idea that we watch a video and that's it. You need practice, and this is what is missing. Unless you practice assembly, you will not get good at it. By watching the videos or these videos, it's not enough, okay? I am giving you the tools, I am giving you the material, you have the videos, but you still need to sit behind the computer and do and code. I cannot. I wish I had something that I can record my stream and put it in your head, but unfortunately I cannot do that. So it is something that you need to do, okay? The other thing is, and I was going to forget this, I was really going to forget this, I cannot forget this. let me find it. Is it this one? Yeah. Yeah. So, for those that do not know, okay, I am, you know, the book that I stream every Saturday and Sunday, Saturday in Italian and Saturday and Sunday in English, okay? I have started, me and Hound Dog have started into converting it in English. We have done till chapter number 3, okay? But as you can see, it's not formatted, and we haven't done the examples, okay? Now, the examples is the headache of the book, because the examples book, okay, is 1,872 pages, okay? So it's not going to happen so quickly to have the book ready in English, okay? It's, let's say I will maybe share some chapters with Patreons, okay? Once they start to look better than they are right now, okay? I just want to show you how this is in the beginning, and you can see the code. I mean, this is in what's in the book in the code. It's not really right, and you can see the instructions, okay, still have the comments in Italian. So this is one thing that needs to be changed, it needs to be fixed. And the source code is the most difficult to change, because even labels needs to be changed because they are in Italian. But anyway, we will do it, we'll test the code, etc. But once I have a chapter ready, as I said, probably I will share it with my Patreons. I will make sure that they will not be able to share it, because I will not be sharing the full chapter, so it will not be complete, but it will help. It will help them for sure if they get parts of it. So this is one of the let's say side projects that I am going to work during the Christmas time, because I'd like to get the first 3 not ready, but a big chunk of it, because there's lots of work, and this is without the examples, okay? The first 3 chapters that are acceptable, but without the examples. The examples will have to tackle them in a different time. I do not see the book ready next year. I have to admit that it's too big. Look at my streams. I haven't even done half of the book, and we are already at number 42 tomorrow. So I do not see that. In episode 1, I told you that I managed to enhance, not me, I did some suggestions, I wrote a video, I did a video, I passed it on to Paul, the where is he? Paul here. I passed the video to Paul. I showed him how I extended this extension my way. It was very crude how I did it, okay? But I wanted to show him that it can be done, basically. And within 1 week, I was going to say 3 days, but I'm going to say 1 week, so not to exaggerate, but actually it was 3 days. I can show you the communication. He came back to me, okay, with the changes that I had implemented. And the changes I did to this extension is that I am able, because I am doing this for beginners. You know, I was getting lots of questions about somebody to have a configuration of the Amiga running, I don't know, as in 1 or as in Pro or whatever, or DevPack, to write code for the Amiga, but they needed the emulator set up, they need all the software set up, etc. So I came up with this idea, okay, of how to have everything, and the extension prepares everything for you. Now, this extension was already to a certain way doing it, but it was not doing it the correct way. So I showed Paul, okay, what he needed to change, and now anyone, you just need to load this extension in Visual Code, okay, write assembly code in it, and tell it to run, and it will start an emulator, and it will run assemble your code and run it in the emulator, okay? And this works, because I forgot to say this works on Mac, Linux, and Windows. So there is no more excuses, okay, for somebody that wants to learn assembly on the Amiga because he doesn't have an emulator or he cannot set it up, etc. This extension solves it all, okay? It comes with two built-in ready configurations, which is the A500 and the A1200. So no more excuses in terms of this. Now, 2 weeks ago, I showed this extension, and yesterday night, or the day before, so Wednesday it was, but it was very late. It was like 1 o'clock in the morning, so it was yesterday. He sent me the update to it, and it is version 1 now. So before it was, as you can see here, it is version 21.3, okay, 0.21.3. Now it is version 1. You can download it from my link, which I will share in a minute, but it will be released, I think, either this weekend or at the end of the month. I did test it from when he sent it to me till just before the stream. I was testing it, and I have confirmed to him that it does what I expect. I'm not saying it's perfect, there's still things to improve in it, but it met my goals of giving this tool to somebody that wants to learn assembly on the Amiga, and it does everything. So I'm just going to share the link for version 1. You can download it. Just give me a second. Let's share. Of course, if you have this opened, you can have it. If you do not have an account in Mega, you need to create an account, but this is the link to the extension. Please download it and enjoy it. I will show in a minute what I showed last week, how to create a project with it, but it's so simple that in future I will, because I do have some more ideas, I will explain how to modify it better, but for now it's good to go as it is, unless Paul, because Paul already knows some of my ideas, comes up with them in the next release. So let me see if I said everything. Yeah, I said this time, I said it, that it works on Linux, Mac, and Windows. Yes, please delete the old version. Okay, delete the old version before you install this one. Okay, and I will show you how to create a project again, but yeah. So let's jump to Visual Code. Guys, you have to bear with me. You see it. You see Visual Code before me. Okay? Just to make you aware. Okay, so I will also tell you some other stuff, but let's close this one for now. We'll open it later on. So close folder. So this is the extension. Okay, here it is. Okay, you install it by going up here and tell it install from VSIX file. Okay, that's how you install it. Please make sure that you remove what you had before. So click here, okay, and uninstall. Okay, I'm not going to do it because mine is the latest one. Now, to create a project is quite simple. So, the usual F1 key, okay, and you can see it here, Amiga Assembly, create example workspace. The example workspace, because it's still coming from the old way it was set up, and it actually will put the old example in your code, but you just need to remove it. So if I click on it, okay, it asks you for a directory. Okay, so I'm going to create a test directory right now, new folder, going to call it test. Okay, and I'm going to select this one. It needs to be an empty folder. This is crucial, that the directory is empty. Okay, so we have, let me do it again from the beginning. If you press F1, okay, you get create example workspace. Okay, we go, I created the directory test, it's empty. Okay, you select it, and this is the next step. Then you tell it what is the name of your source. If you want to call it game, you call it game. I mean, it can be any name, but for main, let's do main, and it's going to create a project, okay, for you with all the files related to the Amiga. As you can see, main.s is the project so I just typed main, but it added the .s extension, and this is the example code. Okay, you can delete it and start typing basically. Okay, to execute, you just need to go to run and debug. Okay, I'm going to select WinUAE because I prefer it, and run it. Okay, and as you can see, I did not have a WinUAE configured and running for the Amiga. It did everything by itself. Okay, this is why I had to delay this series, because I was waiting for this extension to be ready the way I wanted it, in a way. But Paul was very quick and very helpful. And there you go, you have the extension running. Okay, and you can start writing Amiga code. I already explained this all in episode 1, but I just wanted to show you that because there was an update to the extension and it's not yet released, then just wanted to show it to you and know that you need to install the latest release. What I didn't say is that the extension, if you click on it, it should say it is version 1. I do not know where it is, to be honest, but it is version 1. Don't know. There it is. Sorry, there you go. In the window, Amiga Assembly version 1. Okay. There are, you need to go to the wiki to see the changes that were made to it and how it was improved. Paul really did a lot of things to it. I mean, I'm glad I made my suggestions and he followed my suggestions, but it's his work. I didn't do the work, okay? So I'm not trying to take credit. I'm happy that he did it for what I wanted, basically. Okay, if you are wondering why I have these red lines, is because I have an extension called indent rainbow, okay, and it tells me when I'm using tabs and not. In this case, the code was written not using tabs, so it's all spaces, but if I do tabs, then I know I have proper tabs and it uses the type of color. When it's not a tab, and it's also not tab properly formatted, but anyway, forget that. You will see red. Anyway, I do not need to explain this. I went through it in the first example and first video. Okay, so let's close this project. I don't know, do I have to open? File, close folder. No, we don't want to save. That was just a test. And now let's open our project again. This one. Okay, so I shared the source for video number 1, okay, and you can have it, you can download it, and it's in the same where the extension is, and you can download it and you can, while watching video number 1, you can mess around with it. I have added another directory with snippets, okay? This is code that I have taken from the book, okay? I have went through it and changed the comments into English. I'm not saying I'm 100%. For example, this one I haven't done it, but it's self-explanatory in a way. I'm not saying that the comments are perfect, because I might have skipped some Italian might have escaped, but anyway, I hope it helps. I will be adding more snippets so that you can, because I know the book is in Italian and the comments are in Italian, so it helps if you have some code which is, you know, converted into English already, and helps you out. I need to go back to the browser. As always, just the browser before me. So that was done also. Okay. Startup file. So in the first episode, okay, we need to jump back to the to Visual Code. Okay, so in the first episode, okay, I said we are going to use a startup file. And sorry, I'm just going to close the snippets for now. And I didn't explain. I'm just going to move the browser because I will still need it, to be honest, to a different window. what I didn't say why we need it and what it does. Okay, so we are programming the Amiga hardware, okay, to take control of the Amiga, okay, and we do not let the OS take ownership, okay, because the OS will always try to get to the hardware. We are the startup file lets you gracefully take ownership of the Amiga hardware, and like that you can code for using the Amiga hardware without getting, let's say, gurus if you don't take it properly, if you don't take ownership of the hardware properly. So it's setting lots of things in. There's a whole chapter in the book, okay, so I'm not going to, I cannot say what I said, I think in 5 or 6 videos, 6 streams, okay, what the startup file does, every single piece, okay, but know a few things, okay. First of all, the startup file is in includes, and it is still in Italian, okay, but just consider it a black box that you do not need to understand. Just follow its rules. There are websites that provide their own startup file. If you go on Scoopex, Copper Shade, he has his own startup file. I'm using the book one. You can use the one of Scoopex. It will not be the same like mine, okay? Everybody has got his own way of doing it, but at the end, they're all legit, okay? They all do take the OS gracefully the way it should be taken. So, what we need to do to use the startup file? First, we need to add and include. Okay, I will come to the section later on, okay? So at the beginning of our file, okay, of our assembly code, assembly file, in this case we have only one file, okay, besides the startup file. We need to add an include directive, and the include, what it does, it includes a file into our source. Imagine we have a, let's say, a document, okay, with lots of text, and we cut some of the text and put it into another file, but in the end we want them all together, and this is what it does, okay. We are separating the startup file from our code just to be more neat, okay, and at the same time we do not need to know what it's doing. We just need to accept that it's taking the OS gracefully, the way it should, and then once we finish from our thing, we can return to the OS what we took, and it can continue working in the right way. But since we are doing a game, we will never return to the OS except while we are writing the game, but that's a different story. So because as I said, it is an include, okay, so I had to do include and then the include directory and startup.s, okay. Now the startup file wants to know this, okay, the DMA set. This is, let's say, a variable, okay, that we need to tell the Amiga which DMA channels we want enabled, okay. I can go in a lot of detail about this one, okay, and this is also covered in chapter 8 of the book, but what I am going to tell you is that these bits here are enabling the copper, the bit plane DMA, so copper DMA, bit plane DMA, sprite DMA, and sound DMA. This is what we need for our game. So this is why I said game will help you, but the book will give you the details of everything. However, to help you out, okay, this is the DMA con register, okay? So I put all the bits, okay, what the meaning of them, of what each one of them means in above it, okay? The book doesn't do this, but I did it since it's for beginners. And you can see that these four are the audio channels. Okay, we are not going to use disk, but we need sprite, so sprite is on. We are not going to use blitter, okay, and as I said, this game is only till chapter 7. Blitter is chapter 9, so we will for sure not use blitter. I want to show you how you can write a game without having all the complexities, and to prove to you that till chapter 7, by chapter 7 you should be able to start writing games. So that is the main aim of this series. Of course, I already have in my head of how to enhance this series and how I can use the blitter, but for now, version 1 of this game is going to be sprites only, because the aim is to teach you, not to show how good I am or what the Amiga can do. I want you to be able to start coding. And there are other bits like the copper, which we need, the bit plane, DMA. Now there is bit 9. One thing that I didn't say, notice that on top of each bit I made this comment, okay, and that is the position of each bit. This is to help you, so I don't think I can help you more than I did in terms of how I wrote the code. So you can see that bit 9 is this bit, okay? So basically, to enable any of these DMAs, you need to have this bit set, okay? Bit 15, okay, which is also set, okay? When it's at 0, it means you are clearing, okay? When it's a 1, it means you are setting. So when you are changing things, you need to make this a 1, okay? So it's like, as I explained it in the book, it's like, you know, the switches for the electrical switches, the distribution box that you have for a house, okay? You have a master switch, and then you have sections, and each section, let's say, have another master switch, and this is similar how it works, okay? I think I have explained more than enough in relation to this, but it needs this variable, and I will show you why it needs this variable in a minute. Then we wrote our routines to init the bit planes and init the colors that I did in episode 1. I'm jumping these for now. Then it needs, okay, I could have done these after, but I prefer them before. And I tell you why, because here I'm setting the copper. So I prefer anything that needs to be set in my copper list to be set before I call the copper jump, basically. So the startup file needs these, okay? The first one, you can see it's taking the DMA set, okay, the variable that we set what values we need, and it's setting a register called DMA con, and this is the register where you enable the DMAs of the Amiga. Then we need to initialize our copper, and the copper, I'm just going to go you can see I have a label here, okay, couple list, it's this points here, okay, so this is our couple list, okay. I know there's lots of numbers there. I will be explaining them. For your info, some programmers create the couple list using their own program, in the sense they code it, okay. In this case, I want you to learn what is a couple list and understand it. So it is all written as it should be, in a way so that you can learn it, which I will come to that later on. Once we've initialized our copper, okay, as you notice, we move the address of our copper list into register 80, okay. This is an addressing mode in the 68000, okay, that tells it use A5. Now A5 is set up in the startup file and it points to DFF000, okay. I will come to that in a minute. Just assume that in A5, in the register A5, address register A5, there is DFF000, okay. If we do 96, okay, it means we are changing that to 96, okay, so the offset basically. So that is one addressing mode that we have just encountered. Here we have the branch instruction, okay, so this is branch to subroutine, like jump to subroutine in 6502, where we are calling this routine. The .s, it means how far it can go. If it's normally, this is a short because it's down here, so it's plus 128 and sorry, minus 128 and plus 127, but it can be a word. It cannot be long. It can only be word. Branch to subroutine, okay. So normally here in 68000 you specify the what can I call it in this case, how big your data is, okay. So here we're saying that this, because this is an address, a 32-bit address, so it's a long, okay. Here in this case the 0 is a word, so it's a 16-bit address. It's, I don't want to say it is out of the scope of explaining the 68000, but I cannot be, I need to do another series on the 68000 if I had to go through that. I am hoping that at least you watch till at least the first 10 videos of the book, where I cover the 68000 and the copper list and all that stuff. I'm just doing a revision here of what I did in the first 10 videos. But it should help you understanding what we are doing. The move instruction takes a source and a destination, okay. So we are taking, in this case, what's in the data register, the 0, and we are moving it in the address register DFF088, okay, because that 88 is replaced here. Now the address registers, I'm going to go back to the browser, so I'm going to bring it back. The address registers are, you have this link, okay, so are all explained in this page, and this page covers OCS, ECS, and AGA. Okay, all the registers for all three types of chipset that the Amiga have. Okay, now you can see that 88 okay, I told you there is DFF000, and we are adding 88 to it, and this is the copper list or coprocessor restart location, so where it is jumping to, and it is jumping to our address. Guys, you can interrupt me, you can ask questions, okay? This is your time. If you're a beginner, you need to ask questions if you do not understand something. If it's something that I cannot explain right now, I will get back to you later on. I will tell you to come to Discord and I will explain, but if it's something that I can explain right now, I will do it. So please feel free to ask questions, okay? The other register, it was DFF080, and you can see this is where we set the pointer of where the coprocessor is. Notice that each register is a word, okay, but we are doing a move long, so we are moving data into this register and this register, okay, and in fact they are called copper1 LCH, which is the H means for the high word, and the L is for the low word, okay. And please, if I make mistakes, please correct me also, okay? You get points if you correct me. Okay, so let's go back to the code. Here, this is something that you need to accept, okay? These are move instructions that we are moving these values into these address registers to disable AGA. We are doing this for an Amiga 500. To be honest, in the book I haven't yet covered this, but just accept the fact that you need to do this if you're running on an A1200 or an A4000, so that you can be compatible, okay? And the game runs. So I need to, I can see the browser, but you do not need to see it. Just to look at my GitHub, what steps I said. Okay, so I explained the startup file and I explained why it needs. So remember, you always need to add this code by the startup file. I would, any initialization, I normally do it before this part, okay? Because this one initializes the copper, so I do it the last part after the initialization, basically. As you can see, I have infinite loop, okay? Remember, the dot loop means it's a local label, so hence why I tabulated it and I am branching back to it, but it's like this. My code is more neat in my eyes, at least. And I always divide code with these type of comments, the double dash lines. I think I explained what I have in the startup file. Now, one thing I didn't say about the startup file is that it expects a label called start, okay? And if we are returning to the OS, which in this case we are, okay? Sorry, we are not, but if we were, because I have an infinite loop here, if we were, we end up with an RTS and it goes back and restore the OS as it was. That's basically anything related to the startup file. So we've done the startup file. Now I need to explain something related to the couple list before I jump into that. So the couple list, okay, this is our couple list. Okay, and as you can see, it's a bunch of defined constant words. Okay, so basically we're saying that at the memory address where the couple list is, okay, we have this word, then followed by this word, followed by this word, followed by this word. Okay, so that's why DC, defined constant, and the .w is because we are specifying words. Okay, the couple list normally is a word, I mean not normally, it's a word, and it needs to be in an even address on the 68,000 on the Amiga. Now there are other besides define constant word, there is define constant byte, for example. You can define constant byte, but there are let me try to find them if I have them. If not, we will write them. I thought I had. No, I don't. Okay, so you can have, I'm just going to write them after the end, okay, because the assembly will never. You can have define constant byte, you can have define constant word, and define constant long. Okay, so this expects a number from 0 to 255, so it's like that. This expects a word, so you can have as many as you like, separate them by a comma. Okay, and this is a long word, so f, and then another 4. Okay, as we have define constant, okay, we have define storage, and you can have word again, byte, you can have define constant, define storage, same thing, word, and define storage dot long. Okay, and this means that I am allocating, okay, a certain number of, actually I should, let me check, I should, as I said, let's make it bigger. These are assembler directives, okay, which makes you create, let's say, memory allocations with an expression like I showed you. You can define a label to the define constant word, byte, or long, whichever you are using. Like define constant, you can have define constant, define storage as word and as long. I thought you could have also as byte. No, you can have. There it is. So, as per example, okay, you have, I hope you can read it. Let's make it a bit bigger. So, define storage byte, okay, and it's 8. So we are defining 8 bytes, okay. So the number defined after the define storage is how many we want of that type, okay. So all these three define the same length. I mean, all of them are 8 bytes, but in this one we are defining 8 bytes. Here we have 4 words. Each word is 2 bytes, so 4 times 2 is 8, so it's also 8 bytes, okay. Here we have 2 long words. Each word is 4 bytes, so it's also 8 bytes, okay. So in a way all of them mean the same thing, but it depends what you need. Just know that you are reserving a certain amount of memory depending on what you specify after it. That's what it means. Now, like define storage, there is define constant block. So define constant block is the same like DS define storage, okay, but you can specify what the field value is. So you specify the number, okay, and then a value. Let's say you want them all to be contain FF, the bytes. So you specify a value of FF, okay, and the same thing. So there is byte, word, and long word, and you do the same thing. I'm just going to minimize it. So here we had 8, 4, and 2. All of them define 8 bytes, okay. And now I have define constant block dot s, okay, and we can say 8, okay, comma ff. Remember, this is decimal because I'm not specifying a string, and this is hex, okay. The dollar means it's a hex number. And we can do the same actually, and we can say ff. Let's say this one we want it to be zeros, initialized at zeros, and this one initialized, I don't know, 80. Okay, so 80, 80, and this one. To be fair, if I specified 8080 because it's a long, it will do this, to be fair. Okay, so because the number, the length is an address. Sorry, it's not an address, it's a data of 32 bits. Okay, so it's a 32-bit value. So if I specified 8080, it will add zeros to the front of it. And here, it's actually 4 zeros. Because it's a word. Okay, but we specified, we can say 256 and all 256 bytes and all initialized of FF. Okay, so that's define constant these are, I mean, the define constants directives. So now I need to explain sections. Where is section? In my notes. Section should be up here. Okay, so this is where many gets confused in the Amiga assembly. Okay, you'll notice that I have section, and you'll notice that I have another section before the couple list. Okay, now the section directive, okay, tells the assembler, to be honest, not the assembler, tells the OS what data follows. Okay, so here we're telling it that the data that follows is code. Okay, we gave it a name, game code, and also because we didn't specify, it can go into fast mem or chip mem. If there is fast mem or public, I mean, normally this makes more sense, to be honest, if you do this. Phaze101 accepts both, and I think even DefPack. I'm not sure Vesim accepts both. We will see, because I'm seeing that it's not highlighted anymore. So, Phaze101, because remember the extension uses Vesim. When you specify _p, okay, it means public. Public means if you have fastmem, use fastmem. If not, use chipmem. Now in the Amiga, the way where you store your code is very important. Chipmem, okay, so _c, okay, that is considered as chipmem. So the code, because we told it it's code, so this part is understood that it's code. It's this part that specifies where it goes. The Amiga OS needs, or the Amiga, the way it was built, or how it accepts code, you need to tell it when you're coding what is code and what is data. And you need to tell it where data goes and where code goes. Why is that? Because the custom chips only see chip mem. And if you can avoid having your code running on chip mem, it's a good thing, because your code will run a lot faster. Okay? Or will work better. Okay? I'm going to jump back to the manual. As you can see, there are these types. Okay? So the _p is public, the _c is chip, and the _f is fast mem. And we have code, data, and let's say block storage. This is something that when it's loading, it will reserve. I mean, ignore this for now, okay? Because, but there are, for now, just accept that there are these 6. I'm not going to discuss this. So for our code, okay, we need to tell it whether our code needs to go in public, in chip, or in fast. Now, if it's custom, if it's data related to the custom chip registers, okay, actually I need to make it big maybe for you guys to see. Maybe that helps better. So code underscore p means public. Public means if you have fast mem, move my code into memory where it is fast. If I don't, then move it into chip. And in the case of the A500, this is what happened, especially if you don't have the expansion. If it's code related to the chip, to the custom chip registers, then it needs to be in chip mem. Okay, so code underscore C, and the copper, the blitter, etc. needs and sound needs to live. All their data needs to live in chip mem. And this is where sometimes you don't hear music or you don't see graphics because they forgot to specify where it is. And the Amiga loads without, for example, loading your music, and loads it in fast mem when it should be in chip mem, and of course then it doesn't play the sound or doesn't show the graphics, or the graphics are corrupted, but actually they forgot this type of instructions. There are other things that can also affect, so I'm not saying just this, but this was one of the main causes. And code underscore F means fast mem. So all I recommend to you that you use code underscore P. But if you want to force it to be always fast, and you know that your machine is always going to have fast mem, then you can use underscore F. However, as I said, for sound, graphics, anything related to graphics, splitter, copper, whatever, needs to be in chip. Now, what I haven't said, what I'm not making distinction right now between code and data. Okay, now the top part is code, so we don't normally use code underscore C for our code. Okay, normally we use code underscore P. If we want to force it to so that our code is always in fast mem, then we use code underscore F. Okay, there are occasions where you want it underscore C, but normally it's not. Oops, it's not. You don't see code underscore C. For data, okay, as I said, graphics, sound, etc., you will see always data underscore C for section. Okay, if the data, let's say, is somewhere in memory and then you're going to move it into chip mem, then you use P or you use F. Okay, I am touching this part in a way high level, although I have been talking quite a bit. It is very high level. I think it's more, I mean, the book goes in details in this. It's more than enough for what I have explained. I'm not sure if, because this is the illegal section type where I selected, all I needed is to have the section. It said page 62, so let's type 62. Let's see what it gives us. Ah, there you go. And here you go. This is the directive. Okay, it takes a label, can take a label, the section, name, and type. And the types are these. Okay. So this one BS says, as you can see, is a section containing uninitialized data. And you add the underscore P, underscore C, and underscore F, and as I said, fast, chip, and public. I think if I'm not mistaken, def backend as in one they are the same. There were some differences, but in the end, the last versions of them, they are the same. I haven't checked Vesim, I have to say, and the extension uses Vesim, so I don't know if it takes if you can, because there's the option of not specifying these. Okay, certainly for SM1 you do not need to specify them. There is a default. I'm not sure for Vesim you can do that. It's something that one can check it in the documentation. Normally I go for these. Okay, so code underscore p and data underscore c. Normally those are the two that I really use. Hence why this is our code, and we are specifying section game code and code underscore c. This needs to be underscore p, which doesn't seem to recognize it, but then it recognizes code. Maybe the extension, the highlighting of the extension is not correct. I need to check that. Let's see if it takes F. F, it takes it, so doesn't take P. Now, the copper list. Okay, this is our copper. I still haven't explained the copper, okay, but just know that the code or the data of the copper list is in, I called it graphics and data underscore C. So I will come back to the copper, but first I want to cover something related to the 68,000. In the links that I provided, you know, the sheet that I said where you can find all the links, things, there is this website. There is this website of Mr. Jester. Okay, you should have the link. It's somewhere down here. Here it is. Okay, it's this one. So this website will help you learn the 68,000 instructions fairly quickly. Okay, it's not as you can see, let's say the add instruction. Okay, it gives you an example and it doesn't go, what it gives you here, it's enough to get you started. Okay, so I am highlighting this fact because if you haven't followed the book till the first 10 streams, okay, this will help you, let's say, start quicker in a way. Okay, as I was saying, the 68,000 instruction set is the instruction plus the size, then source and destination most of the time, and the source and destination can use one of the addressing modes. There is also, I mean, although it might seems a lot, but not really. It's not a book, you know, it's quite short, so it gives you a quick start of how you start using the 68,000, because I do not have time to explain the 68,000 in all, but there's also another link and it's also explained the addressing modes, and this is one of the things that you need to understand. Okay, and it is not a long page. It covers the addressing modes fairly quickly. Okay, so you shouldn't have issues. There's also another link which is, let me find it. Not sure if it's this one or this one. Actually, yeah, it's these two, and they are actually the same, but I have them here open. Oh, you will not see them like this. Okay, this one goes in detail, so I'm referring to these two links. Okay, this one and this one, and so keep this in handy. I mean, when you are doing things, it's just reference them. This one goes in a lot more detail than what that page does, but then whether you need all this complexity or not, it's up to you, but it also gives you all the addressing modes that it supports. Okay, and whether it's long, whether it's word, etc., some exceptions, etc. So that's one thing, and then there should be another one. I'm not sure if it's this one or this one. This one. This one I use a lot. It's just the instruction set. Okay, there is the same, there is more detail, there is an explanation. Okay, so I'm referring to this link here. Sorry, not on this one, because this one is the official Motorola Programmer's Reference Manual. Okay, this one is just the book that I'm showing, which now I lost. Was it? I opened it in the browser. No, it's here. Okay, and it goes into more detail of what of the instruction set. This I expect you to go through it or use it as a reference while you are coding. So right now I'm just giving you the tools. Like, we haven't really started the game. I'm just we have just a canvas, and I am explaining things before we start, because I know the Amiga is not like the 64. No, you need to have certain things and certain tools, which some people do not understand, that you need this to even start and do something on the Amiga. Okay, you need to understand the 68,000, have an idea of it before you even start coding. You need to have an understanding of the section, the assembler directives, some of them, not all, but what they do and why they are there. Now that I have explained that, yeah, there is, I'm going to open it, click on it and open it. ScoopX, Photon of ScoopX has got this page. You can go in copper shade. Okay, it's here, copper shade. But what I want you to see is this image. Unfortunately, okay, I have this. I noticed it's only in a few days that this has happened. I have a reference to the Amiga Memory Map. Okay, I will show you. This was the amigacoding.com website. For some reason, it's not there anymore. It doesn't exist anymore. It's like it went down. I mean, I don't know. It had a very good Amiga Memory web page. Okay, very good one. It specified it by machine, and that's what I liked about it. Unfortunately, it's not there anymore. Hence, the best one I found in terms of explaining it is the one of ScoopX, and I hope that Photon doesn't mind that I'm sharing his page. Where was it? Was it there? Now notice, remember this DFF000? It's the custom registers. Okay. So all the custom chip registers starts here related to graphics, okay? Because there's the CIA ones, which starts at B. Here they are, BDF, BFD, and BFE. Okay, for the mouse button is at BFE. Okay. The Amiga 500 had 512K of chip mem, which is OCS. The Plus had ECS. Okay, so it had till 1000000. Remember, this is the start of the second one, so it's actually F, 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 F. So because Photon didn't do till when it ends, but it makes sense. I think you can understand that it is the memory is 1 byte less than the current address. Okay, not 1 byte, 1 byte less than the current address. So the Amiga 1200, which was AGA, had till 1FFFF chip mem. Okay, this is quite an important thing to know or to look at. So when you know how the addresses start in the Amiga, tells you where you are manipulating things. For example, kickstart is FC. Okay, now if we had the one that I used to like or still like, but it's not there, this varies a bit between one machine and another, but in essence this is right. The reason why is because of the certain not the addresses. I mean, it's not that the custom chip change address, but there is more detail depending. If you, for example, if you have an Amiga 4000, there is more detail where, for example, the Zorro card goes, okay, and things like that. That's what I meant by things vary a bit, because here they are not shown, but it shows quite good where chip mem is for each model. Okay, and this is quite an important, this part in yellow is quite an important thing to know. Okay, that one and this part, because you'll be using it a lot where the custom chips are. Remember, we are programming the hardware directly, so you need that. So I've been 2 hours talking. I took just 5-minute break. I don't feel like having another break right now. I'm just going to continue, but I still don't think I'm going to finish what I had planned. But I hope that you are enjoying it. And please ask questions. I haven't seen anyone interrupting me, but if you do not understand something, please ask. So, where is... I think I moved away from... Yeah. That's naughty of me. So, the memory map I explained. Now, and this I think is where I will end, because there is not enough time to explain all this, but I'm going to explain the copy list. So we will end up by having a copper bar on the screen, I promise you that. It's not going to be in a 5-minute job, but we will do it. So let's go back to our code. You need to know two things about the copper. Okay, there are 3 instructions of the copper, but we're only going to discuss 2. One is a move and the other one is a wait. These, okay, this is a move. Okay, this is a move. You tell me, how do you know it is a move? Well, remember I told you that A5 we had DFF000 as address register. The copper built into it has got something the same. So it knows that if we are calling, if we have O12C, okay, it knows that this is an register that in front of it, ignore this 0, okay, it's like that, it has got DFF. This is built in by default. Okay, I just do 0 to make them all for text ASCII letters. Let's put it that way, for numbers, hex. So when it's a wait, let's see if I have a wait here. Don't I have a wait? Nowhere. Okay, I do not have a wait, but this is end of copper. When you see this pattern FFFF, comma FFFE, that means ends of copper list. And notice you specify everything in Word. Okay, now I'm just going to do this. You can see that I have 180 and then 0, 182 and then FFFO, 184 and F. So what are these? These are the colors for our screen being set up. Okay, we have 4-bit planes for our screen. Okay, so we are using 16 colors. Okay, 180 is color index number 0. 182, remember every register is word, so then the next one is 182, because it's 2 bytes, is color index 1, and we continue like that, okay, till 19E, which is color index number 15, because we start from 0. So if I had to look at the map of registers again here and find 180, so I passed it. See, 180 is color 0, and you can see we have 32 of these, but we are only using till 19E, which is color number 15. Okay, I think this is simple now. How we are doing the move instruction, basically we're telling it whatever you have following this value, put it inside the register. So 008 goes into 018C, which is color index number 6. Now the copper list is made up of many registers. One of them are the colors. Okay, but we have the bit plane pointers where our screen is, okay, which we initialized last time. Let's find it. This is the routine that we wrote last time to put values here so that the copper knows where our screen is, our bitmap is, okay, which is the image that we display on the screen. Same like the bit plane, there is the sprite data, okay. We initialize the sprite pointers, okay, with zeros, so that, and then we populate them. So it's one of the things that we did, okay, in episode 1. There is a reason why, I mean, I know that you are seeing a label here and a label here, but okay, I'm just going to, for a moment, remove this. And notice that they are in sequence, one after the other, okay? I just put a label to that memory location. So to this address here, I have a label called enemy sprite pointer, okay? Because this is where the enemies for the sprite number 2, from sprite number 2 till sprite number 7, that means 6, we have our enemies. And we load the high value here, the high word here, and the low word here, okay? And if you look 1 to 8 in that map, you will see it is this sprite high pointer, okay, high word for sprite number 2. So that is the move instruction. So what about the wait instruction? Okay, so here is the setup. Okay, here I have the colors for the sprite. Okay, so these are the colors of the sprite. Okay, so now you know what I did. Okay, these are setting the register with the colors for the sprite. The colors can change, okay? I just have values for testing purposes, okay? Even here, in fact, they are overwritten by our routine that loads the color for the image, okay? But I have values there that they are there for testing. So all these are colors, okay? Then we have the bit plane pointer where it is, and we populate this with our image that we have here. We are loading the image, this image, okay? So that's how we are able to see an image on the screen by this got an address, which is the address that we have labeled. We have labeled it as game screen bit planes, okay? And we just load that address for each bit tree, because all bit planes are there, into that part of the memory in the copy list. Okay, so we update the pointers. For now, I won't cover that. Okay, it's the collision detection, which I just prepared it. You don't need to know it. Here is we're telling the Amiga register 100, okay, how many bit planes we have. So we have low res, 16 colors for bit planes, of course, and that is done by specifying this bit specifies whether we have high res or low res. You can see bit 15 here, okay? And if not mistaken, these three specify, yeah, these 3 bits here specify how many bit planes we have. Bit plane 4 is 0, 0, 1, no? If you had to specify it in bits, it is bit 3. So for bit planes it's 001. That means for bit planes is automatically 16 colors. So we haven't this one is setting the dimensions of our screen and the modulo, how it is, etc. This is chapter 5 of the book, which is further than number 10, but please accept these values as they are. This opens a 320 by 256 screen, and we can display an image on it. If I had to go into this, I will take a lot of time. Maybe another time I will explain it, but for now accept that we open the screen with these values. Here we initialize the sprite pointers with 0. So there you go. You have an explanation of all the couple list. What there isn't is a weight. So how do we specify a weight? This is how you specify a weight. Let's say we need to specify, we need to tell it we want to wait for line, I don't know, 70 hex. And we start from the beginning. So the beginning is normally 07, not 00, okay? Or not 01. This value, okay, has to be odd. It cannot be even, okay? If you try to do even, the Amiga will crash. It will not give you a guru, but it will halt because it needs to be an odd number. So accept that it's 07 for a line, okay? The book goes more in detail into that. Just accept this thing. And then, so we told it, wait for raster line 70, okay, hex, and it needs a mask, and normally that is FFFE, like what you have here, okay? So we are waiting for line 70. What do we want to do then? Let's say we want to change color 0. So we take this register, okay? And this is color index number 1, no? Sorry, number 0. And we want it to be white. Remember, our background is it's RGB, okay? The first 0 is empty, 0, okay? So we have told it that at raster line 70, okay, on the screen, it will be a white. Then it's very easy. Let's say we want to change that at 80. Okay, so 16 lines down. So we want to return to black. So we do 0, 0, 0, and that is black. Okay, so now if we run our program that we did, I hope it still runs because I haven't checked it, but if we run our program, we should see that our background changes from black to white and then again to black. Let's run it. I spoke a lot today explaining things, and we haven't done a lot on which related to the game, but I think it's something that is needed. So let's run it. It's going to load our image eventually. There you go. And as I told you, look at line 70, okay? It turned from black to white, and then at line 80, of course 80 hex I'm talking, it turned from white to black, and it continued as we did. Now, this is, you know, is not what I want to show you. This is just a start, because the wait command is very powerful. So now let's create a copper bar. And to do that, I'm going to remove the image that we have on the screen. This is why last time I was, in episode 1, I was in a way hurrying up to have a screen set up so that I can start showing you things, okay? Because I felt if I don't do this, you will not be able to understand. So I'm removing the image, but we still need our bit planes. So we do define constant storage, okay? Dot byte, and we need, so our screen is 320 pixels, so it's 40 bytes times 256 lines, 256, I mean the height of our image, and we need it times 4 bit plane, 16 colors, so times 4, and we initialize it at 0, no? So that the memory is cleared with 0. We also need to initialize the color byte. We have 16 colors, and each color is a word, so times 2, and we initialize them with 0 also, okay? So we're going to set up the screen with a blank image basically now, instead of our image that we were including as part of our assembler. And let's see that what I define constant not as block. My God. Let's see what I was going to okay, sorry. So let's run it. First we need to save it also and run it. There you go. We have a blank screen. Okay, we set up the bit planes, everything, but they are blank. They are initialized to 0. And we have our bar in the middle, white bar that we created. Now, that's not nice, no? Let's do what we were used to see on the Amiga, okay? Having a copper bar. So, let's find our this is our weight. Let's do this. Maybe this will be 90 now. Okay, and let's do it there. Now, imagine we are going to change the color of our background 16 times. Okay, why I'm saying that? Well, so this still so forget the weight for now. Okay, I'm just going to do this so that you maybe understand better. Should have done it before. So instead of white, let's start from black, but black we already have the background, so 001. So the first, sorry, blue, let's do it blue instead of white, but let's start from 1 because 0, 0, 0 is already, we have it. Okay, and now let's change this each time by 1. So this becomes 2, and we continue like this. Why did I do? So not going to end, so I better delete all this and do this. And this becomes 4 now. And do this, and this becomes 5. 6. Now I'm doing it manually, okay? You can imagine you can create a routine that does this, okay? That creates this copper bar via a routine, not like I'm doing it manually. 8. But to understand, you need to know how it works. So, okay. E. There. Okay, you can see the colors changing here. I mean, this is something that is helping me in the assembler, in Visual Code. So these are all the colors. Now the weight needs to be incremented now, so not 70 for each one of them, but needs to be the next line: 71, 72, 73, 74, 75, 76, 77. So can you see how you can create a loop, a routine that creates all this? 7A, 7B, 7C. Okay, we need, so this is from 1 to F. Now we need from F to 0 now to create the copper bar. So a way of inverting them, but anyway. So this is where we have the F, and now we start changing this again to E, D, C, B, A, 8, 7, 6. Okay, so the other thing that we need to do, okay, so that was 7E, so this is 7F, no? This one is 80, 81, 82, 83, 84, 85, 6, 7, 8, B. Now, AD is this one. We always need to return to 0, no? We need to change the color back to 0, so this should be 8D. Okay. So now, if we run it, given that I don't have mistakes in it, okay, we should see our copper bar. Let's see if I made any mistakes. As I said, this is normally created by a routine. No, you don't do this manually, but to show, there it is. Our copper bar is there in blue as we specified. Okay, now, okay, you can imagine, okay, you can write a routine to move it up and down, okay, by modifying the value here. Okay, so you write a routine to increment this value each time, and you are moving it further down and then decrementing it further up. So this is something that the book covers so much in detail, these type of routines. So I am just going to show you, okay, first let's exit from the one that we have here. Okay, let's go to now my Amiga. Okay, you should be able to see my Amiga. Let's I'm just going to show you what we did and how it can be expanded. Okay, so because in the game we will not be doing this, but I wanted to explain to you how the copper works, because we are using the copper and the wait command is quite an important part of it, although we are not really using the wait, we are just using the move. Okay, so I believe it's in here. I don't know, I'm just going to grab one. I think it's this one of them. Let's see, we have just one line. Okay, just one line, and it's going up and down, changing the color, but there are many of these. Okay, I just grabbed one. Let's do H. I think H is a collection of all. Okay, so this one is a bigger one. Instead of if you don't see it smooth on the screen, it's not because it is not smooth on the Amiga, but because of the stream. Okay, so that's one of the reasons why you might be seeing it like that. However, that one, instead of every one line, it's doing it every 2 lines to change the color. And then of course having the bar changing the color also horizontally. So I specified always 0.7, but you can change that into an odd number, increments of odd number. So after 0.7 is 0.9. Don't do 0.8 because the Amiga will crash there. So let's see if there is, I can show you some more. Pretty sure there were some big ones. Yeah, for example, this one. You can see it moving up and down. There's a copper in the background in blue at the top and at the bottom, and then the red copper bar moving up and down. So this is how to manipulate the copper. This part, okay, I'm going to leave it, but in the next episode we will not need this copper bar. The game doesn't use a copper bar, at least so far. Maybe in the beginning when it starts, but so far it doesn't, and we do not need it. I just wanted to show you what the copper needs, or what we need for the copper. So let's exit that. This code will be, you'll be able to download it from the links, the public links that I have for this, and same for the video number 2. I mean, stream number 2 will be available on YouTube, so you'll be able to get that too. So guys, wish you a good weekend and hope to see you next week. Thank you. Thank you, Fraudwin. I hope it was good. Thank you very much, and see you next week. Thank you, and bye-bye.